Hi, I'm JD, and in this lecture, we're going to be going over graphs and functions. We're going to start by going over the basics. We're going to look at how to plot points. We're going to look at function notation, and then we're going to look at how to graph things. So we're going to graph using a table method. We'll also graph by using the intercepts. We'll graph using slope-intercept form, or using slope-intercept form, and then graph using slope-intercept form, and then we're going to look at parallel and perpendicular lines. So how to plot an ordered pair. So this is the XY plane, also called a Cartesian plane, and it has 4 quadrants. 1, 2, 3, 4. It's like a shape of a C. Then you have the x-axis and the y-axis. Now, what is A? What is point A? So with points, you have an x-coordinate and a y-coordinate, kind of like the latitude and longitude on your GPS, to tell you where you are. So you always start with the x-coordinate, so it would be 4, and then your y-coordinate would be 2, so this point right here would be 4, 2. Now over here in quadrant 3, now let's look for B. So you see where it lines up, the x-coordinate is -3 and the y-coordinate is -5, so this would be -3, -5. So let's look at some more points. So 3, 4, x-coordinate is 3, y-coordinate is -4. 0, 2, that would be B. So that's slightly out of order. You can also consider x to be the way that you're shifting from left to right. So with letter B, it's not moving left to right, it's just moving downwards from 0, 0, which is the origin. This is 4, 0. Right there, 4, 0. So it moves to the right 4, and it's not going up or down. This is -2, 4, so this would be letter C, so -2 for the x, and then going up 4, you land there. And then A, 3, and then down 4. Alright, so here's function notation, and function notation f of x is the same as y. And you would say function f of x. And it's just giving a label to a function, because we're going to see that when you graph, it's like y equals something. And if you have a bunch of lines, you want different names. And so you label them this way. And x is your input, y is your output. Now here's an example of function notation. So let's say f of x equals x squared. F of 3, so this is telling you that your x is 3, your input is 3, and so you put it into the function, which is x squared. So just do substitution, so 3 squared, and then whatever comes out is your output. Same thing with f of 5. It's not f times 5, it's f of 5. So it's telling you to input 5 and see what the result is. So you input 5 for x, replace the x with 5, so it would be 5 squared equals 25. And you get an output of 25. What this means is that your x is 5 and your y is 25. So you can either write this as the point 5 comma 25 with parentheses around it, or you can write it as f of 5 equals 25. So let's look at what's called a relation. And a relation could either be a series of points that they give you, or it can be represented as two circles where you have input and then you have your output. These lines represent the function, so you're going -2, plugging into the function, and out pops the y, which would be 4. And it continues to do that. So you have input and output. X is your input, y is your output. So what's the domain? The domain are all your x values. Here it would be -2, -1, 0, 1, 2. For your range is the second component, or your output. So here it would be 4, 1, 0, and it looks like it repeats, but that's okay. You only have to list it once. Now, is this a function or not a function? Well, if x has a unique y value, it doesn't necessarily mean that the y's can't repeat. The x's can't repeat. So if your x, -2, has 4, and each one has its own separate y, even though they repeat, it's fine. It would be a function, because what you put in is what is going to come out. So let's look at another example. Determine if it is a function and find a domain and range. We're going to find a domain and range first. We're going to go slightly out of order. So again, we have input and then we have output. And again, these lines represent the function. So if I put in a -2, out pops a 4. Put a -2 again, out pops a 1. 0, 0, 1, 1, 2, 4. Kind of similar to the last one, a little bit different. The domain is going to be -2, 0, 1, 2. Just all those x values. Now your range is going to be the same as the last one, because it has the same numbers, 4, 1, 0. Now, is it a function or not a function? Well, because -2 for the x has both the 4 and the 1, so -2, 4, -2, 1, for one x, there's two different y's, it's not a function. So for one x, if there's two different y's, it's not a function. So if the x's repeat, it's not a function. If the y's repeat, it doesn't matter. It's still a function. But here, since the x's repeat, for one x you have two different y's, it's not a function. Alright, so this problem is asking, determine whether 1, 4, 0, 6, and 3, -4 are solutions of this equation 4x plus y equals 8. Now, to determine if it's a solution or not, all you have to do is plug it in. So I'm going to rewrite the problem. 4x plus y equals 8. And then just take what you have, 1, 4, and you're going to substitute. So 4 times 1 plus 4 equals 8. Now you're checking to see if it's true or not. It is true, so therefore it is a solution. Alright, let's look at 0, 6. Always rewrite the equation before you plug it in. And and we're going to plug in 0, 6. The reason why you would do that and why I'd suggest it is because sometimes you might write the problem incorrectly. And so it would be a way to check your work. So when I plug it in, I get 4 times 0 plus 6 equals 8. That's 6 equals 8. That's not true. So therefore, 0, 6 is not a solution. All right, the last one, so I have 4x plus y equals 8. I'm plugging in 3, negative 4. So it'd be 4 times 3 plus negative 4. 12 minus 4 equals 8. That's true, so it is a solution. And that would be a way to check to see if there are solutions or not, just simply by plugging them in. So let's graph by plotting points. To do that, you just list out your x's and you're just plugging them in. Now you can use any x's you want. Sometimes they might give you the x's to plug in. But for the most part, you know, if it's a line, then you only need really 2 points. So you would use the third one to check yourself. Now again, you can plug in any points you want. So you want to make them both easy and convenient. So that's why I would suggest -1, 0, and +1. All right, so let's first plug in x equals -1. So if I plug in x equals -1, that's -3 times -1 minus 2, which would be 3 minus 2, which gives me 1. So that's my first point right there, -1, 1. Now I'm going to plug in 0. So x equals 0. Plugging into the equation, -3 times 0 minus 2. This is 0 minus 2, which gives you that -2. So I'm plugging that into my table. So now I'm going to plug in x equals 1. So I have -3 times 1 minus 2, and that's going to equal -5. Forgot the equal sign there. But that's okay. That was a mistake on my part. Anyway, so then what you do is you plot the point. So -1, 1 is right there. 0, -2. Again, is where they line up. And then 1, -5, which is right there, right? 1 and then down 5. Now after you have your 3 points, now just draw your line. Alright, now let's graph by using the intercepts. So let me set up my table first. Now what we're going to do is we're going to look for the y-intercepts first. The y-intercept, the x is always equal to 0 and the y is some number. Now these calculations are going to be easy, but if you're prone to make mistakes, just write it out. So that would be 7 times 0 minus 2y equals -4. So 7 times 0 cancels out. So it's -2y equals -14. Might have said -4, but it's -14. Then divide both sides by -2. Y equals +7. So my y-intercept is 0, 7. Now let's find the x-intercept. Your x-intercept, your y is always equal to 0. So you're going to do the opposite. Plug in 0 for x now. Sorry, 0 for y. So that would be 7x minus 2 times 0 equals negative 14. That cancels out, leaves you with 7x equals negative 14. Then you divide both sides by 7. You get x equals negative 2. Plug it in the table there. So I got my 2 points, my y-intercept, which is 0, 7, and my x-intercept, which is negative 2, 0. So my my y-intercept is there. Y-intercept falls on the y-axis. So where the line intersects with the y-axis. And then you have the x-intercept, which falls on the x-axis. Falls on the x-axis, negative 2, 0. So where the line hits the x-axis, that's the x-intercept. Now draw your line and you're done. So we're going to use slope-intercept form. So with slope-intercept form, if you can get it into slope-intercept form, which is y equals mx plus b, you would do that by solving y and simplifying. If you can do that, then just by looking at it, you know what the slope is and you know what the y-intercept is. So let's solve for y and then simplify. So we have 2x minus 3y equals 9. I'm going to subtract 2x from both sides. The 2x cancels, leaving with negative 3y equals negative 2x plus 9. The negative 2x plus 9 does not combine because they are unlike terms. So this would then divide. You would want to divide to cancel it out because it's multiplication. So divide everything by negative 3. Now here, since it's separated by a plus sign, when you multiply both sides, you have to distribute. Or divide, you have to distribute. So you're dividing everything by negative 3. You get y equals 2/3. You get rid of the negative, you simplify. Negative by a negative is a positive. So you get 2/3 x. 9 over negative 3 simplifies to just negative 3, or you can put minus 3. So now it's in slope-intercept form, which is y equals mx plus b, where m is your slope and b is your y-intercept. So just by looking at it, you know what the y-intercept is and what the slope is. Here the slope is 2/3. The y-intercept would be negative 3, and you can rewrite that as a point 0, negative 3. So when you see something like this and it's asking for the slope and the y-intercept, you want to put it in slope-intercept form, because then you can just compare that, find the slope, and find the y-intercept. To do that, you just solve for y and simplify. So how do you graph by using slope-intercept form? So let's say that we have y equals 2/3 x minus 7. You would want to write out y equals mx plus b. Now m is your slope, which is rise over run. So to do this, you start with your y-intercept. Then you're going to use rise over run. So you're going to rise, you're going to go up, and then you're going to run. So you're going to rise 2 and then run 3. And then you're going to put your point. Now the slope continues on up 2 over 3, up 2 over 3, up 2 over 3, and that continues on with the line. But once you have 2 points, you can draw your line. So now let's look at parallel and perpendicular lines. So parallel lines are lines that do not intersect. So they're lines that do not intersect. Now they're going to have the same slope but different y-intercepts. You could just say same slope, but technically if they have the same slope and the same y-intercepts, they're the same line. So you're always comparing two separate lines here. Perpendicular lines, perpendicular means a right angle. So it's where two lines intersect and form a right angle. Now to notice that they're to identify that they are perpendicular, you look at the slopes, and if the slopes either are negative reciprocals of each other or opposite reciprocals, meaning the signs are different and they flip, or what you can do is what it says there, the product of their slopes is -1. So if you multiply them together, it's going to give you -1. So let's look at some examples. So this is y equals -5/7 plus 4. M means slope. This symbol right here means parallel. So a line that is parallel to this is going to have a slope that's the same. So that would be -5/7. This symbol right here kind of looks like forms a right triangle. Sorry, a right angle. That's forming a right angle and it's intersecting. So it's perpendicular. Symbol for perpendicular. So the slope of a perpendicular line to this is going to be opposite and reciprocal. So opposite, you're going to change that negative to a positive. Reciprocal, you're going to flip it. So it's 7/5. Let's look at a different problem with parallel and perpendicular lines. Let's say that you're to identify if the lines are parallel, perpendicular, or neither. The best way to do this is by looking at the lines in slope-intercept form. So I have 2x plus 3y equals 6. To get it in slope-intercept form, all you have to do is solve for y and simplify. So I'm going to subtract 2 from both sides. That gives me 3y equals -2x plus 6. Again, the two x's cancel. These don't combine because they're unlike terms. I want to get rid of the 3, so I divide everything by 3. And that gives me y equals -2/3 x plus x. Now this is in slope-intercept form. Now I'm going to look at this one, solve for y and simplify. So I'm going to get rid of that 2x. So I'm going to subtract and do the opposite. So subtract 2x from both sides. I get -4y equals -6 plus 10. Then I want to get rid of that -4, so I divide everything by -4. And I get y equals 3/2 x minus 5/2. Now, if I look at both of these slopes, right, it's y equals mx plus b. So the m, which is in front of the x, would be the slope. So the slope for this one is -2/3, and then for this one is 3/2. And what I would do is I would go through this. So are they parallel? Parallel means are they the same? The answer is no, so they're not going to be parallel. Are they perpendicular? Are they negative reciprocals of each other? So if I take this, change the sign, and flip it, do I get this? And the answer is yes. Another way to tell is if I multiply those two slopes, -2/3 times 3/2, and you get -1, then it's perpendicular. These will give you, when you do that, you do get -1. So they are perpendicular. Now that's it for Unit 5. So what did we go over? We went over plotting points, x-coordinate, y-coordinate. You always start with the x-coordinate first. X-coordinate is shifting from left to right, y-coordinate up and down. We looked at function notation. Function notation is f of x, and that's the same as y. And it's just giving a label to the function. We also saw when it's not a function that if we to have like points, if for one x there's two different y's, it's not a function. We looked at different ways to graph. So we looked at the table method, just putting in any points or any numbers that we want. We looked at graphing by using the intercepts. And then we looked at slope-intercept form. So how to find slope-intercept form, y equals mx plus b. And then we also looked at how to use slope-intercept form to graph. Then we looked at different types of slopes. And when it comes to parallel and perpendicular, you're comparing more than one line. So it's always going to be in a pair or more than a pair. And you're asking, okay, are they parallel? Do they have the same slope? If they have the same slope, then it's parallel. If the slopes of the two lines are opposite reciprocals of each other, that means the sign changes and you flip the fraction. If it's like that, then it would be perpendicular. And that's it. That marks the end of this video. Please like, share, and subscribe. And if you have any questions, put them in the comments below. Thank you, and I hope you have a wonderful weekend. All right, bye.